My guest today is Pranay Kotasthane of the Tech Geopolitics program at the Takshashila Institution in Bangalore. Pranay, welcome. Glad to have you.
Yeah, glad to be back, Surya. Thanks.
So we are talking about critical minerals, and this little conversation flows from a thread that Pranay had put out on X a couple of days ago. So we're going to try and break that down and get him to explain things that perhaps were not amplified in that message. So Pranay, critical minerals. Give us an update first on the critical mineral situation worldwide. And just for the sake of our viewers, would you just break down what are these critical minerals and where do they go?
Right. So, critical minerals, the term has been used a lot in the last few years. So, it's
Mm.
better to understand what they are, and then we can begin to talk about the geopolitics of it. So, the CRS, the Congressional Research Service, had a very nice paper where they try to define what critical minerals are. They are essentially non-fuel minerals that have two characteristics. One, they are essential in use, so they are used in a lot of places. And second, they are subject to supply risks. So these
Mhm.
risks might be geologic, technical, environmental, social, political, or economic. Right. So whenever you have things which are non-fuel materials that are essential in use and they're subject to supply risk, they are called critical. So that's pretty much the definition. They are non-fuel, which means when we talk about oil, critical minerals are not like oil. There's a
Mhm.
critical difference is that oil is a fuel. So when you use oil for your vehicle, the oil gets burnt up and you have to fill oil again in the next after a few days. That's not how
Yeah.
critical minerals work. They are materials. So they are there in your phones, they are there in your vacuum cleaners, they are there in your laptops in very minute quantities because they have some specific quality which makes them useful. For example, permanent magnets are important for many things from vacuum cleaners to defense applications. And neodymium is a rare earth, which is a subset of a critical mineral, which is used because it has certain characteristics which makes permanent magnets more efficient at lighter weight. So that's why they use it in this. So differences: oil is a fuel, critical minerals are materials. Oil blockades can cause economy wide inflation, right? Imagine if, but critical minerals are not like that. It's not as if when critical mineral things are stopped you will have an economy wide inflation. There will be some inflation but not that kind. And the quantities that are required of critical minerals are really minute, which means you can do stockpiling and recycling to a greater extent than you can do for fuels, right? I mean, we can't
Mhm.
stock oil for a year. We can
Yeah.
stock oil for a few days. So these are like main differences that critical minerals have. I'll just talk about the geopolitics, not the what is critical, etc. So this term critical minerals is of recent origin. In
Mm.
2002, Spain had come up with a priority minerals list. So that was the first time this focus came about. And there's a very nice paper by the Stockholm Institute for Peace and Research. So they had analyzed how this term came into being. So it was not in common use. That 2010 Senkaku Islands dispute between Japan and China was the first time. So China didn't officially declare something, but it did
Mhm.
stop the supply of critical of rare earths to Japan. So because of that, a lot of nation states started taking notice that this is something that can happen again. And then many countries started defining their own critical mineral list. So 2011 was when the US started defining a critical mineral list, and today nearly 20 plus countries have such a list.
Mhm.
The US critical mineral list has around 50 elements, and in India we also have a critical mineral list which has 51 elements. The thing is
Okay.
that there are such a large number of elements, which I mean, it's almost half the periodic table. So it doesn't make sense to define such a broad list. But anyways, many
Mm.
countries have critical mineral list, and they define everything from graphite to germanium to rare earths as critical.
Mhm. So there is currently a squeeze on the supply of critical minerals.
Right. So Now, with this definition as critical minerals, there is a subset of critical minerals called rare earths, right? So,
Hmm.
even though the term means rare earths, they are not actually rare to find. They can be found in many places, but they are being economically extracted and processed in only a few places.
Hmm.
And one mine in China, in Inner Mongolia, is a very big source of rare earths, and they have also done processing, etc. Well, so the squeeze is happening because China has a very big play in the refining and processing segment, right? So there is, if you look at the supply chain, there's the first step is extraction, which will include mining,
Yeah.
extracting of these minerals, and these are found generally they are co-located with each other, or they are a byproduct of something else. For example, gallium is generally a byproduct of alumina. So wherever aluminium mines are there, you will find gallium in small quantities. But what generally happens is you extract aluminium, you use it, but unless the price of extracting that gallium from that ore is good enough, you will not convert it and process it and refine it. So
Hmm.
in China, because there were huge subsidies, this processing stage is also very environmentally polluting. You have to do acid leaching, solvent extraction, etc. So Chinese companies were willing to do that, and that's why they became slowly dominant in the processing and refining segment. Now, what has happened with the geopolitics of US and China is that China doesn't have instruments like the US has. Like, they can't stop ASML from giving chips to US, right? US
Yeah.
can do. So China has to respond in some way, and one way they have responded is by saying that these critical minerals, because we have some dominant role here, we will put licensing requirements for companies to export them to the US and to some other countries. So that's why the squeeze has come in the recent few years.
Hmm. Critical minerals are easy to find, you said, but difficult to extract.
Yeah,
Is that
they
what you're
are.
saying?
No, they are rare earths are not rare. They are, that's a
Mm.
misnomer. They are found in many places, but to economically refine them and process them
Hmm.
is difficult, and you need to also do a lot of investment. It's just like any other mining project, right? You need to first do
Uh-huh.
a good exploration. You need to ascertain that the quantity that is present there is good enough for you to do 3 years of mining. Then you need to be able to refine and process it. So refining and processing is where the current challenge is, not so much in extraction. Extraction is the
Hmm.
first step, which is essentially mining and separation of minerals from other co-located materials.
So that's a dirty job,
Yeah.
separating
So
these.
yeah, separating the processing refining requires, it's, so the general process is called solvent extraction. So it's not some,
Hmm.
very complicated technology or process. It's just that, in fact, the this processing solvent extraction techniques were devised in the West in the 1950s. But
Hmm.
over time, what happened is the environmental costs were huge. The West wasn't willing to do that, and they said it's very similar to how semiconductor manufacturing moved to Taiwan, right? So
Hmm.
they said, why do this? There's not much value in it. We'll do the high-end design stuff. Let you guys do the dirty stuff if you want to do. Someone
Hmm.
else can do it. Chinese companies said, okay, we are willing to do that. They were also subsidized by the government, and they were willing to take that cost, and hence all the processing, refining slowly moved to China in for rare earths. And for other critical minerals also, China slowly became a major player. And yeah, so acid leaching is a dirty process. It pollutes the environment, and yeah, that's the trade-off. Do you want
Hmm.
that, or do you want critical mineral refining? You have to decide.
So, was it the environmental issues that prevented us from going forward on looking for these rare earths and processing them, or was it something else? It was not on our radar.
For India,
Yeah.
yeah, so for India, there were a couple of reasons. So again, in critical minerals, I'll divide them into rare earths and non-rare earths. So
Yeah.
let's take non-rare earths first. For example, gallium. So gallium is often used for chips which are used in, let's say, for specific applications, wideband gap semiconductors for defense applications, some radars, etc. So now there is a mine of for aluminium is produced in India, is extracted, processed in India, and the one of the byproducts of that is also gallium. It exists in India, but again, that ore which exists, the gallium ore, you need to do a lot of processing and refining to eventually get gallium out. India is not doing that currently because China is just giving gallium at such cheap rates that people just prefer to buy from China instead of processing that gallium, etc. So if you look at some of the reports that the Institute of Mines in India brings out, they always say we have gallium, but we are not processing it. So it was not economical to do it because you are getting it for cheap from China. So that is for the non-rare earths. If we look at rare earths, again, China has overall gotten so much dominance that generally countries said that, if they are selling it for us at cheaper rates, why would we do that?
Why
And
bother?
remember, this rare earth, the quantities required are really small. So the entire US demand last year of all rare earths combined was just $170 million. So, and that too has declined from $186 million in 2023. So it's not as if like oil or something, right, which is required in billions of dollars. So companies were just willing to let China do this job before it put these export controls. But now they are now thinking, we should do that. In India, the rare earth challenge was specifically one more complicated because India's rare earths, light rare earths, are co-located in monazite sands, which is also a source of thorium. So
Yeah.
these things come under the Department of Atomic Energy, and the Department of Atomic Energy's focus was on using monazite sands for atomic purposes, thorium,
Yeah.
and not rare earth. So rare earth was like a second or third, fourth priority for the Department of Atomic Energy. Only recently, and there's just one government company called Indian Rare Earths Limited, which was allowed to mine and extract. So
Yeah.
recently, the government has changed its stance. Now, apart from first of all, there was some deregulation done last year. There was a bill which removed some of the restrictions for other companies to come in. So now private companies can come in order to mine these. And probably we'll now see more things happening with the National Critical Mineral Mission also.
So now the Chinese are putting the squeeze on the world, and does that hit us also?
Yeah, it will, but not to a large extent right now because we finally buy the end products which are made through these rare earths. Anyways, my whole point is that this kind of ransom that China is trying to take by putting these export controls won't hurt the world to a large extent, and in fact it will take out the overcapacity that China itself created in rare earths, right? Because they are putting export controls, now countries are realizing that you need to build your own capabilities, and that was not possible earlier, like I said, because if you wanted to extract the gallium from the Indian mine with the ore of which exists, you wouldn't do that because you'll just prefer to buy it cheaply from China. But now, because China has made it clear that it is going to use critical minerals as a geopolitical instrument, then other countries will do that. The prices of gallium, germanium, and others will rise. That price rise will make it economically viable for a company in India or the US to actually do the processing, refining, and then bring it online. So that's the big change which has happened.
So with China putting the squeeze, where does one go for rare earths? I've been reading some reports about tying up with Argentina or Chile and some of these other countries. So what does that involve? Is it buying mines? What is it?
Yeah. So Argentina, Chile are not so much for rare earths; they are for lithium. So lithium is a critical mineral, not a rare earth, but that is used in our electric vehicle batteries, etc. So that
Yeah.
is why it is important, right? So yeah. So India does have Kabil, it is called, which is a the equivalent of ONGC Videsh Limited, where
Yeah.
they are trying to collaborate with other countries. So it involves a lot of co-investment in third countries where the mines exist to extract and then refine, process. Those kinds of things are happening. But actually, there are a bunch of things that countries are trying to do over the last few years, because this problem is not of a recent origin. As I said, it
Hmm.
happened in 2010 when China made it clear. So the story of Japan is very interesting. Even though people remember 2010 incident, they don't realize what did Japan do after that. And in fact, Japan has tried to substitute sources. It builds stockpiles, invest in urban mining. That is, can you recycle these minute quantities from your phones and vacuum cleaners, etc., and partner with other countries. So these are the four things Japan has been doing. The net result is very interesting to know. Japan is less dependent on China's rare earths than it was in 2010. In fact, now the dependence is less than 60%. In 2010, it was 90%. So they've
Okay.
significantly reduced. And Japan, in fact, consumes half the rare earths today than it consumed in 2010, because they have made it more efficient. Right. So if you do efficiency improvements through newer research, you will require micrograms of neodymium rather than milligrams,
Hmm.
right? So that kind of work has happened, and those are the kinds of things countries will have to do.
Hmm. So what you're saying is that although China is a major processor of these rare earths, their hold over the market may not be as absolute as it may be made out in newspaper reports.
Yeah, so their hold on the market exists, but I don't think it is a powerful geopolitical leverage for them.
Hmm.
And many times the news reportage on critical minerals is very bombastic, very, uh,
Extremely.
yeah, it's saying like, I mean, if you don't get critical minerals, the world will come to a stop. No, that's
Yeah.
not the case. In fact, China has put the ban on gallium and germanium for the last 1 year. Did you or I
Hmm.
come to know about it? We didn't, because
They didn't.
either there are stockpiles or people are trying to find alternatives. So in the short run, we must expect that prices will rise, because obviously
Hmm.
these mines and things can't come up suddenly. But this price rise itself will make other projects outside China viable. And as I said, because the quantity is $170 million in the US, right? Even if it becomes
Peanuts.
10x,
Yeah.
US companies will be able to absorb it. But a
Yeah.
lot of news reporters hype is about the hype on critical minerals, so we need to be more sanguine about it.
Hmm. So you mentioned substitutes in that X thread of yours. What are these substitutes? And
Correct.
is it possible to make them here?
Yeah, yeah. So I will talk about four kinds of substitutions that countries have been trying to do. So first, and this is like common things that critical mineral engineers, scientists try to do. So what they try to talk about is, one is material for material substitution. So for example, earlier electric vehicle batteries used to use a critical mineral called cobalt a lot, but
Hmm.
cobalt is found only in a few places, and Indonesia, etc. So people started thinking, what are the alternatives for it? And now, if the Tesla and others pioneered this technology called LFP, which is lithium iron phosphate batteries. So now a lot of the newer electric vehicles use LFP technology, which does not use
Hmm.
cobalt at all. So these kinds of things are called material for material substitution, where you eliminate one material which is bottlenecked for one way or the other. So that happens,
Hmm.
and iron is more abundant than cobalt, so you don't have to have a problem. So that is the first one. Second, people try to do system for system substitution. So this is slightly tougher than material for material substitution, but system for system substitution involves, for example, can you replace lithium ion batteries with hydrogen fuel cells? So already that has happened to a certain extent in very heavy load trucking in the US. They are trying to find alternatives. Can that be done? Even some Indian companies have been trying this. So hydrogen fuel cells is an example of doing system for system substitution. The third one is process for process substitution. Here, what you can do is you can recycle critical minerals from old electronics instead of mining new ones. I think this is
Hmm.
where India can has an comparative advantage, we can do things here, because as I said, they are required in small quantities. So if we are able to find out policy ways to encourage, let's say, urban mining. Urban mining essentially means recycling, collection of electronic waste, and extracting the process to get the critical minerals in small quantities back for use, right? So process for process substitution is also a third way, and the fourth one is efficiency improvements itself. So when you do some research, you find out ways in which, why is this neodymium being used in a permanent magnet, can you make it more efficient, then the
Mhm.
amount of neodymium that you require for achieving the same purpose declines over time. So these are all four things that are used. India and other countries will have to do a mix of all of them. But for us, especially because the interesting data point here is starting a new mine always takes a lot of time. The International
Yeah.
Energy Agency estimates it takes an average of 16 years to start a mine, right? So you need to find ways to do recycling, process for process substitutions, or do research such that you don't require the rare earth or others at all. Those are the kinds of things that we need to focus on.
Mhm. In every official VIP visit, the joint declaration that comes out invariably refers to cooperation on critical minerals, rare earths, supply chain diversification, so on and so forth. Um, uh, but the narrative still kind of centers around China. You know, it's not
Hmm.
that we seem to be going beyond that. Although I
Hmm.
guess a lot of work is still going on behind the scenes. So
Hmm.
that's what it's about. Basically, influencing the course. I mean the
Yeah. Yeah, so actually, a lot of things have been happening on the diplomatic side, because finally the problem is, are you willing to take that environmental pollution, etc., if you want to
yeah,
start a
yeah.
new mine, right? So some countries are, some countries aren't. So for that, diplomatic engagements help a lot. So again, three or four things have been happening. For example, the US started something called the Mineral Security Partnership,
Yeah.
which is to catalyze public and private investments into certain mines. So essentially, they give a thumbs up to certain projects that, this is something which we are backing, and hopefully catalyze investment from private and public players. So 32 new projects have been approved under the Mineral Security Partnership in many countries. 19 of them are extraction and mining. 15 of
Hmm.
them are for midstream processing, which I told you is where China has the lead, and three of them are on recycling and recovery. So that is already on. The EU has already started a critical raw materials club, which is again somewhat similar. Apart from that, countries are thinking about joint stockpiles, right? So essentially,
Hmm.
if China tomorrow stops a certain thing, can we collectively have a stockpile, so that at least for the immediate short-term spike you can manage. So many countries have their own stockpiles, but they are also thinking, like, in Quad, can we have a joint stockpile, or can so that's one way. And the final way is, of course, joint research, because if you do
Hmm.
want to do long term substitution, you will have to figure out a way in which, how can you replace, how can you do research as that the neodymium you require is 0.1% of what you require now. So for that, you need
Hmm.
to do research, and research can happen better if there is collaboration across many universities and
Hmm.
companies. So that these are the kinds of things which are happening already, since China has used this time and again, and countries are trying to find ways out, and diplomatic instruments are one way to achieve that goal.
Hmm. Given that we here in India tend to recycle a lot of things, I presume recycling even things like rare earths, critical minerals, and the stuff that comes out of it may
Hmm.
be fairly well established here.
Uh, I think it requires policy clarity for this.
Hmm.
So right now we are not doing a lot of it, because again, it was just, why to do something because you can buy it
Yeah.
from China itself. But with all these things happening, there will be a incentive to do this. The government has recently launched. So the things that government has done: first, there was as I said, you couldn't even enter into the rare earth space. Now you
Yeah.
can. Second, there is a recent national critical mineral mission which has been launched by the government, and before
Yeah.
that the government came out with a list of critical minerals. So now there's some clarity emerging, and in this national critical mineral mission the government is giving upfront capital investment if you want to explore certain materials and minerals. So that's a good thing, right? The earlier exploration was not happening. For example, I mean, I'm sure you would have come across this news which said that in the J&K's Riyasi district, we have found a lot of lithium reserves,
Yeah.
and that
Yeah.
lithium reserves will solve our
Mm.
problem. You would be surprised to know that that block has still not been sold, even
Mm-hmm.
as we speak. So nothing has
Yeah.
happened there. We just said we found something, but really nothing has happened on the ground. But because the reason why it has not happened is because the way things take place is, first you have to do a lot of exploration, and you have to give a
Yeah.
confirmation that lithium is available in this concentration, this much of it is available. Then a mining company will be willing to invest money. But we didn't do
Mm.
any of those explorations. We just put that block on sale and no one bought it. So now with this national critical mineral mission, they are trying to do give upfront capital investment for companies to prospect these minerals, etc. So we need some policy changes of this nature, which gets people interested in this domain, removes the uncertainty involved, and then things will improve.
Mm-hmm. So, last question, Pranay. Critical minerals may not be that critical a thing for India in terms of availability and all that. It would still be available, perhaps for a little higher price. And given that we are looking at mining our own stuff, perhaps a few years down the line, it may not be an issue at all.
Yeah, I think I would agree that they are not as critical as the news suggests to be, but they are important. Let's say, for example, lithium will be important for electric vehicles, etc. So we have to have a narrower list of what is critical minerals. Defining
Mhm.
50 minerals as critical doesn't make sense. And once we have a narrower list, then we can, the kind of policies we were talking about, those can then help us build a capability for that. And we should also think of the diplomatic options as one way. We don't need to build a stockpile ourselves, right? If
Mm.
Quad can build a stockpile, or if India can build a stockpile with other friendly nations, then our problem can be managed to a large extent.
Mhm. So a stockpile would be held in some country or the other, and anybody who wants it can go and buy.
Correct. So there will be,
Mhm.
like, I mean, there are, if you have put 20% money to build that stockpile, you get 20%
Y-
out of it. Those
Yeah.
kinds of arrangements are often done in other areas and can be done here
Hmm.
as well.
Is this something that likely to happen going forward?
Yeah, I mean, this has been discussed in Quad and other segments. So already, like I said, in mineral security partnership, projects have started, and maybe
Yeah.
this, but no joint stockpile of involving India has been announced yet. But
Hmm.
hopefully, it could be, with China doing these things. It is becoming all the more urgent, relevant for other countries to do these kinds of options.
Pranay, thanks very much for that perspective. I mean, one is relieved to know that China's handle over these critical minerals may not be as overpowering as it is sometimes made out to be. And it's also a good thing that we are going forward on our own exploration and processing. So let's hope the policy mandarins get their thing right. Thanks very much, Pranay. Great talking to you.
Thank you, Surya.
That's all we have for you on this broadcast. Do subscribe to our YouTube channel and follow us on social media. Thank you very much. Good day.